Hi, this is Math 1340, and this video is over Chapter 8, 8.2. And we're going to look at a system of equations when we're dealing with three variables and three equations. And for this, what you're looking for isn't necessarily one point, but it can be a whole plane sometimes that ends up being a solution, about how they may cross. And there's still a possibility that with three variables that you may end up having no solution. Or you may have what's called a dependent solution where um, it still depends on a couple of variables. Your solution does, that is. I'm going to do an algebra way of doing it. You're going to see that using algebra, it will take a little bit longer to do than just a system of two equations. You're basically doing it twice. And then I'm going to show you a way of doing it on a calculator that involves matrices. And this would probably be the quickest way of doing these. Alright, so let's say we have 3x minus 2y plus z equals 1, x plus 3y minus 4z equals 2, and negative 2x plus 5y plus z equals negative 19. So what we want to do is we want to look at what two equations can we use to eliminate a variable? And then we want to eliminate that same variable using a second set of two equations. So one equation we'll use twice, but we have to use all three equations. So looking at this, I can eliminate x when I use the top two equations by multiplying by negative 3 on the bottom one. Or I can eliminate x by multiplying the bottom two equations by multiplying the middle one by 2. So that's what I'm going to do. So the first one I'm going to do is I'm going to use these two equations, multiply the top by 2. 2x plus 6y minus 4z equals 4, be minus 8z. Gotta make sure you multiply everything by your 2. And the bottom one I'm not going to manipulate at all, because the x's then cancel out. So I'll end up with 11y plus negative 7z equaling 23. Make sure I did that right. 7y, negative 8 plus 1 would be negative 7, 23. Now I'm going to do the top two equations. I multiply the middle one by a negative 3. So 3x minus 2y plus z equals 1. And negative 3x minus 9y plus 12z equals negative 6. When I add them, I get negative 11y plus 13z minus 5. This doesn't always happen, but the fact that we have 11y and negative 11y actually helps us out here. We're going to now add these two. The y's cancel out. We get 0, that'll be 6z and then 18. Then divide by 6, you get z equals 3. Okay. That's your first solution, or part of your first solution. Once you get a value for x, y, or z, you know there's going to be one solution, one x, y, and z solution. So now what we do is we work our way backwards. We take one of these answers and we solve it for, or one of these equations and we solve it for y. I'm going to take this equation, solve it for y. So 11y plus negative 7 times 3 equals 23. So 11y is -7, -21 equals 23. 11y equals 44. So y equals, when you divide by 11, you get 4. So this is your z, this is your y. Now that we have that, we find an equation for x. I'm just going to use the middle one since x is by itself. Actually, I'm going to solve it for x. So 2 minus 3y plus 4z. Now we plug in what we have for y and z. So 2 minus 3 times 4 plus 4 times 3. 2 minus 12 plus 12 gives me 2. X equals 2. Right, so your solution is 2, 4, 3. That point. Okay, so these somehow work to do this algebraically. Now, if we want to do it through matrix, there's one thing we got to do is we got to set up the equations so it's easy to put into a matrix. What that means is we need to basically have a column of A, a column for B, a column for C, and a column for the answer, or the right side, you can say. So 10a minus 48b equals -30. The only thing we gotta do is think about what c would be. We have 10a minus 48b plus 0c equals -30. Then 5a plus 28c will have 5a plus 0b plus 28c equals 22. And the last one we have 0a plus 48b plus 42c equals 66. We'll put this into a matrix. A matrix would have 3 equations, so we have 3 spots going down, 3 rows. And there's 4 across. There's 3 variables plus your right side, so you have 1, 2, 3, 4. And it's basically all the coefficients here. So you have 10, -48, 0, -30, 5, 0, 28, 22, 0, 48, 42, 66. All right, so now what we got to do is use what's called a R reference, but we have to first get the matrix in the calculator. Right, so here's how we get in the calculator. You do math, oh, I'm sorry, second matrix, and you'll see names, math, and edit. And then you have A, B, C. These are basically all the matrices you can store. So this is the name of the matrix is A. Usually that's all I do is change A. So what I do is I'll go to edit. So second matrix, edit A, and you hit enter. And then we gotta change it so it has the right number of columns and rows. Right now it's 1 by 1, so it's 1 column, 1 row. We want it to be 3 by 4. 3 times, as you see, they put 3 rows in times 4. Okay. So change to rows times columns. Then we put in our values. So insert values. Insert coefficients. 10, -48, 0, negative 30. Make sure you put the negative sign in, not the minus sign as you do these. Oops. I go back and fix that one. I was 0. Where? Then 5, 0, 8, 22, 0, 48, 82, and 66. Just double check, make sure you have everything in correctly. Negative 30, 22, 66, 0, 28, 42, negative 48, 0, and 48. And this one's 10, 5, and 0. Okay. So now, once you are out, what you do is second quit. Second quit. That's the only way I found to get away out of the matrix. Then we'll do second matrix again. But this time, instead of going, we see that we have a 3 by 4. So now we know that's our matrix. We're going to go over to math. We're going to do R reference. And I think it's the 10th one. No. B on this one. The B will be R reference. You just hit enter. Then again, go back and do your second matrix. And this time you will actually choose your matrix A. Math. No, not math. Second matrix. Use matrix A. Close your parentheses. Enter. And you get your solution. Now, how the solution is. You'll have 1, 0, 0, 0, 1, 0, 0, 0, 1. And then that would be your x, y, and your z. And then you have your solution 1.2, 0.875, 0.571428. Okay. These are decimals. I may be able to convert it to fractions. Let me see. Math fraction. Yeah, you can convert it to a fraction too. So this is 1, 1, 1, 0, 0, 0, 0, 0, and 6/5. Close the thing too soon. 6/5, 7/8, and 4/7. So what this means is x equals 6/5, y equals 7/8, and z equals 4/7. Based on how we plugged it in, what's x, y, and z, or I switched to x, y, and z, we had a, b, and c. So a, b, and c. I'm used to doing x, y, and z. A, b, and c. Okay, so a is 6/5, b is 7/8, c is 4/7. Then we can write the solution as 1.6/5, 7/8, 4/7. Now, there is a chance that you may have where a whole row has zeros for your A, B, or C, or X, Y, or Z. That means that there's probably no solution, especially if there's a number, so it's saying 0 equals 4/7, for example. That would be a problem, and you're not actually getting a solution. You also could have other values here, so you could have 1 for the first column and a 1 in the first row in the third column. That means your solutions depending on multiple factors there. Okay. So now let's say we have a jar of coins, contains nickels, dimes, and quarters. Total is $6.75. So we're going to do N for nickels, and a nickel is 5 cents, so 0.05 for the nickel, plus 0.1 for the dime, times how many dimes, plus 0.25 for the quarters, times how many quarters, and that has to equal 6.75. There are 3 fewer quarters than nickels, so the number of nickels has to equal the number of quarters plus 3. Adding 3 to the number of quarters to get the number of nickels. There are 3 more dimes than the total number of nickels and quarters. So quarters plus nickels plus 3 is equal number of dimes. So we can write these now as a matrix, but a couple of the equations we want to adjust. So we're going to need nickels minus quarters plus 0 dimes equals 3. And the bottom one be, let's see here, nickels plus quarters minus a dime. So I'm subtracting the dime over equals a -3. I'm subtracting the -3 over. Let me just double check this right. Right, so we can write this now as a matrix. 0.05 for your nickel cost, and then 1, 1. This would be nickels. Quarters be 0.25, and -1 and 1. Dimes be 0.1, then 0, -1, and then for cost, 6.75, 3, and -3. Or I shouldn't say cost, the value. Find the cost in the first one. All right, so that's what we're going to be changing that matrix to. So, on second matrix, hit it. We still have a 3x4. Change each one of these. So 0, 5, 0.25, 0.1, 6, 7. I'll have to make points. 6.75. And 1, -1, 0, 3, and then 1, 1, -1, -3. So let me double check. 1, 0, -1, 0.25, -1, 1, 0.05, 1, 1. Okay. Quit. And so we'll do second matrix or reference, and second matrix Put in the value for A. So our solution here, we get 1, 0, 0, 15, 0, 1, 0, 12, 0, 0, 1, 30. So that is basically saying N equals 15, Q equals 12, D equals 30. We got 15 nickels, 12 quarters, 30 dimes. If you think about 12 plus 15 is 27. That's 3 less than how many dimes you have. The nickels and the quarters. Quarters is 3 less than how many nickels. And then if we calculated this out, let's see, you got $3 with the dimes. You got $3 with the quarters. That's $6. And 75 cents with the nickels. When we have a total of 42,000 was invested in 3 accounts. First account paid 6% simple interest, the second account paid 4% simple interest, and the last account paid 3%. The amount deposited in the first account was twice the amount deposited in the second account. The total interest after 1 year was $1,680. We want to find the amount invested in each account. So we'll do X, Y, and Z for each of the accounts. So first, second, third. So the total was 42,000. So X plus Y plus Z is 42,000. That's your first equation. The total interest is 1680. So X times this interest, which is 6%, 0.06, plus Y times 0.04, plus Z times 0.03, that has to equal 1680. And then the last equation we're going to need, the first account paid, let's see, the amount deposited in the first account was twice the amount deposited in the second account. So 2 times Y equals X. Okay. The first two are set up pretty much like we need them. This third one, we'll have to adjust that. So that's going to be X minus 2Y plus 0Z equals 0. And so we can put this into a matrix. We're going to do 1, 1, 1, 42,000. Then 0.06, 0.04, 0.03, 1680. And then 1, negative 2, 0, 0. We'll do that first. So 1, enter 1, enter 1, enter 1,000. Then 0.06, 0.04, 0.03, 1680. And then 1, negative 2, 0, 0. So 42,000, 1680, 0, 1.030, 1.04, negative 2. In the first row, 1.06, 1. Okay. So second matrix, math, all reference. Oh, see, this is why you have to exit out of that. So let's see if we can get back to it. That's going to be just one. Okay. Second, quit. second matrix down to reference, and then second matrix A, and 1 0 0 0 1 0 0 0 1 and 12,000. So 12,000 in the first account, 6,000 in the second account, and 24,000 in the last account. So this is written as x equals 12,000 or 12,000 in first account, y equals 6,000, 6,000 in second account, and the last one z equals 24,000, so 24,000 in third account. Okay. All right. Here we're going to have a table of data. So we have the table shows the average number of afternoon newspapers sold each day in a certain small town since 1995. So in 0 years since 1995. So in 1995, there was 1,420 newspapers sold each day on average. In 2005, which is 10 years later, there's 1,448 newspapers sold on average. And then in 15 years later will be 2010, there's 1,492. We want to find an equation that's going to be a quadratic equation that fits this data, or x is the number of years from 1995. So here's how we do it. We use those three equations, or those three data points. So for when x equals 0, y equals 1420, and so this means I have a times 0 squared, following this equation, plus b times 0 plus c equals 1420. You can kind of see with these zeros, we're going to get c equals 1420. This actually isn't that bad to do it by hand if we wanted to, because we already know what c is, kind of, if you just look at it. But it's a good way to check it too. Next one, x equaling 10, y equals 1448. This is going to be a 10 squared plus b times 10 plus c equaling 1448. And then the last one, x equals 15, y equals 1492, a times 15 squared plus b times 15 plus c equals 1492. So your matrix here, your coefficients are actually going to be the values of your x's. So 0 squared is 0, 10 squared is 100, 15 squared is 225. And then 0, 10, and 15, and 1, 1, and 1 for C, and 14, 20, 14, 48, 1492. All right, so we'll plug those in. There it is. Second matrix. Enter. So we get 0, 0, 1, and 1420. And then 100, 10, 1, 1448, then 225, 15, 1, 1492. Just double check these. First three columns look good. So second quit, second matrix reference, then second matrix, your matrix A. Then I get 1, 0, 0, 0.4, 0, 1, 0, and 1.2, and 0, 0, 1, 14, 20. And we said that 14, 20, obviously, if you look at the first equation, you should get that for C, and that's what we got for C. So A equals 0.4, B equals negative 1.2, C equals 14. So a function is going to be 0.4 x squared plus negative 1.2, so minus 1.2 x plus 1420. That is our function. Now we can use that to find an estimate of how much will be sold in 2015. 2015 then is 20 years later, so x is 20. So when x is 20, f of 20 is going to be 0.420 squared minus 1.2 times 20 plus 1420. So 20 squared times 0.4 minus 1.2 times 20 plus 1420. We get 1556. So the estimate for 2015 is 1,556 newspapers. Okay, and so the next section we'll look at another way of doing this with matrices, and then we'll keep going. I'll see you then. Bye.